السلام عليكم أعزائي الطلبة. وصلنا للمحاضرة الثامنة Respiratory Physiology اللي هي محاضرة diffusion. Objectives راح نحكي على diffusion, partial pressure of gases, respiratory membrane, diffusing capacity, and ventilation per diffusion ratio. After the alveoli are ventilated with fresh air, the next step in the respiratory process is diffusion. اللي هو diffusion of oxygen from alveoli into the pulmonary blood and diffusion of carbon dioxide in the opposite direction out of the blood. The process of diffusion is simply the random motion of molecules in all directions through the respiratory membrane and adjacent fluids. However, in the respiratory physiology, one is concerned not only with the basic mechanism by which diffusion occurs, but also with the rate at which it occurs. This is much more complex problem requiring a deeper understanding of the physics of diffusion and gas exchange. Physics of gas diffusion and gas partial pressure, molecular basis of gas diffusion. All the gases of concern in the respiratory physiology are simple molecules that are free to move among one another, a process called diffusion. This is true for gases dissolved in fluids and tissues of the body. For diffusion to occur, it must be a source of energy. This is provided by the kinetic motion of the molecules themselves. For free molecules that are not physically attached to others, this means linear movement at higher velocity until they strike other molecules. Then they bounce away in new directions and continue until they strike other molecules again. In this way, the molecules move rapidly and randomly among one another. Net diffusion of a gas in one direction effect of concentration gradient. If a gas chamber or a solution has a high concentration of a particular gas at one end of the chamber and low concentration at the other end, مثل ما نشوف هنا بالفيجر, the net diffusion of a gas will occur from the high concentration area to the low concentration area. نشوف هنا هذا هو مثلا diffusion of oxygen from one end of the chamber اللي هي من هنا باتجاه النهاية الثانية. The difference between the lengths of the aurora represents the net diffusion. هنا هاي منطقة بها high concentration of oxygen, هنا بها low concentration. طبعا الديفيوجن راح يكون بالاتجاهين، لكنه محصلة الديفيوجن هي راح تكون من الهاي concentration area إلى low concentration area. The reason is obvious. There are far more molecules at end A of the chamber diffused towards the B than there are molecules diffused in the opposite direction. يعني هو ببساطة الموضوع إنه هنا لأنه هواي molecules تتحرك باتجاه المعاكس، هنا اكو molecules أقل تتحرك باتجاه المعاكس. المحصلة هي بالهاي concentration area إلى low concentration area هو هذا النت diffusion. Therefore, the rate of diffusion in each of the two directions are proportionally different. Gas pressure in a mixture of gases, partial pressure of individual gases. Pressure is caused by multiple impacts of moving molecules against the surface. Therefore, the pressure of a gas acting on the surfaces of the respiratory passage and alveoli is proportional to the summated force of the impact of all molecules of the gas striking the surface at any given instant. This means that the pressure is directly proportional to the concentration of gas molecules. In respiratory physiology, one deals with a mixture of gases, mainly of oxygen, nitrogen, and carbon dioxide. The rate of diffusion of each of these gases is directly proportional to the pressure caused by the gas alone, which is called the partial pressure of the gas. The concept of the partial pressure shall be explained as follows. Consider air which has an approximate composition of 79% of nitrogen, 21% of oxygen. The total pressure of this mixture at the sea level is 760 mm mercury. It is clear from the preceding description of the molecular basis of the pressure that each gas contributes to the total pressure in direct proportion to its concentration. Therefore, 79% of 760 mm mercury is caused by nitrogen اللي هي تساوي 100 أو 600 mm mercury، with 21% of oxygen اللي هي تساوي 160 mm mercury. Thus, the partial pressure of nitrogen in a mixture is 600 and the partial pressure of oxygen is 160 mm mercury. The total pressure is 760 mm mercury, the sum of the individual partial pressures. The partial pressure of individual gases in a mixture are designated by the symbols PO2, PCO2, PN2 dual nitrogen, or PHE dual helium, and so forth. Pressure of gases dissolved in water and tissues. Gas dissolved in water or body tissues also exert a pressure because dissolved gas molecules are moving randomly and have kinetic energy. نفس الشيء مثل ما يكون بالاير يكون بالwater. Further, when the gas dissolved in a fluid encounters a surface, such as the membrane of the cell, it exerts its own partial pressure in the same way that the gas in the gas phase does. مثل ما هو يكون له partial pressure بالgas phase يصير له partial pressure بالfluid phase. The partial pressures of the separate dissolved gas are designated the same as the partial pressure in the gas rate. نفس الشيء PO2, PCO2, PN2 والPHE اللي هو الهيليوم and so forth. Factors that determine the partial pressure of the gas in the fluid. The partial pressure of the gas in a solution is determined not only by its concentration but also by the solubility coefficient of the gas. That is, some types of molecules, especially carbon dioxide, are physically or chemically attracted to water molecules, whereas others are repelled. When molecules are attracted, far more of them can be dissolved without building up excess partial pressure with the solution. هنا نشوف السوليبيليتي coefficient لل CO2 يكون هو يختلف عن أعلى من السوليبيليتي coefficient للأكسجين، ولذلك يحتاج إلى partial pressure قليل حتى يصير به يكون dissolved مقارنة بالأكسجين. When molecules are attracted, for more of them can be dissolved without building up excess partial pressure within the solution. Conversely, in the case of those that are repelled, a high partial pressure will develop with fewer dissolved molecules. These relations are expressed by the following formula here Henry's law. البارشل pressure يساوي concentration of the dissolved gas على solubility coefficient. يعني شنو معناها من هاي المعادلة؟ إنه كل ما كان solubility coefficient عالي كل ما نحتاج إلى partial pressure قليل اللي هو مثال عليه منه CO2. كل ما يكون solubility coefficient قليل نحتاج إلى partial pressure عالي حتى يصير dissolved gas. نشوف هذا الجدول. When a partial pressure is expressed at atmosphere 1 atmosphere pressure equal to 760 millimeter mercury, at concentration is expressed in the volume of gas dissolved in each volume of water. The solubility coefficients for important respiratory gases at a body temperature are the following. نشوف هنا الأكسجين ونشوف الكربون دايوكسيد هنا 0.057 هنا 0.024 بينما نشوف الكربون مونوكسيد 0.018 نيتروجين 0.012 والهيليوم 0.008. نشوف هنا كمقارنة بين الأكسجين وبين الكربون دايوكسيد اللي هم أهم respiratory gases يخص اللاج. نشوف هنا الكربون دايوكسيد هو solubility coefficient مالته أعلى تقريبا 20 مرة مقارنة بالأكسجين. From this table, one can see that the carbon dioxide is more than 20 times as soluble as oxygen. Therefore, the partial pressure of carbon dioxide for a given concentration is less than 1/20 that exerted by oxygen. مش قد ما يكون solubility coefficient عالي قد ما يكون الغاز more soluble